Okay, here. So we said that the structure of DNA contains a nitrogenous base or nitrogen-containing bases. So we have 4 possible nitrogen-containing bases here. 2 of them we call that purines. 2 of them are pyrimidines. Purine, they are adenine and guanine. We just use A and G for that. And then pyrimidine, they are thymine and cytosine. So we have this, but the purine will pair with pyrimidine. So they will have we call it it's a rule. It's like a base pairing rule. What does it mean? Usually I would just tell students that okay, for the so A and G, they are purine. And then T and C, they are pyrimidine. Well, let's put it this way. And A will form hydrogen bond with T, and G will form hydrogen bond with C. So when DNA forms a double helix, so one helix will have all this base pair, and then the other pair will also have something called complementary base pair. Complementary base pair meaning that A always bond with T, G always bond with C. So if one strand of DNA you have A here, then the other strand must have a T on the opposite side in order to connect. So we'll talk more about this complementary base pairing rule later. But how I tell students to memorize is that A bond with T, G bond with T, so it will be like at guidance center, So this is the one way to put it, or you can call it at golf course. So this is one way to help you to memorize. A go with T, G go with C. And in here we said that DNA is a polynucleotide. It's like a polymer. DNA is like a polymer. It's a long chain. And it's a strand with the backbone. The backbone of the DNA is basically a phosphate group and sugar. So the phosphate group and the pentose form the backbone, and the base, ATGC, they form the bridge. You may call it, they form the connection to join two strands of DNA together. So I'll give you you can think about this. Which molecule have you learned so far? I will give you tips. The molecule is one of those macromolecules that has a very similar structure as the nucleotide. As nucleotide. So it is a nucleotide, okay? Nucleotide. The structure of nucleotide, do we have it? Let me show you. Okay, we'll have this later. So I'll tell you the answer in the next video. Which molecule looks very similar to the nucleotide. Now, we all know that DNA is a double helix. What does it mean, double helix? Meaning that you have one strand of DNA, and then you have another strand parallel to it, and then after this, well, this is my usual demonstration. One strand of DNA, you have another strand of DNA, they are parallel, and then they are connected with the ATGC, or the base connected in the middle. And then what happens is that, and then they twisted. So they twisted like this. So this is what we call the double helix. And then the strands are connected by hydrogen bond. Hydrogen bond here is the connection between the base. So A always pair with T by hydrogen bond. G always pair with cytosine. C by hydrogen bond. So and they call it anti-parallel. What does it mean? When we talk about anti-parallel, we have to know that the strand of DNA, they have direction. What kind of direction they have? First of all, we need to take a look at the structure of the nucleotide. The structure of the nucleotide, let me see. Do we have it? So this is what I meant, double helix. And then it is anti-parallel. What does it mean, anti-parallel? First of all, look at the structure of the nucleotide, the monomer. You see that this is a pentose sugar. This is a nitrogenous base, and this is a phosphate group. And you can see that the carbon atom we can number the carbon atom. Carbon atom 1, carbon atom 2, carbon atom 3, carbon atom 4, and carbon atom 5 here. This is not a carbon atom, this is an oxygen here. So after we number the carbon atom with a 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, then what happens is that at the 5 prime end of the carbon with a 5 prime, we connect it with a phosphate group. And at the 3 prime end of the carbon, we connect with a hydroxyl group. And because of that, they are connected in this way. So this is 5 prime end here and 3 prime end here. So this is 3 prime end, this is 5 prime end. That's why we call this as the 3 prime here. Because this is the 3 prime carbon atom here. And we call the phosphate group as the 5 prime end because the phosphate group is connected to the 5 prime carbon. And as you can see that one strand of DNA is going this way from 3 prime to 5 prime, but the other strand is the opposite direction. 3 prime is at the top, but 5 prime is at the bottom. Because of this arrangement, we call this anti-parallel. In addition to that, you can see that A form hydrogen bond with T and C form hydrogen bond with G. And the number of hydrogen bond is also different. When A forms hydrogen bond with T, it forms 2 hydrogen bond. C forms with G, it forms 3 hydrogen bond. So this is a base pairing rule. So on one strand you may have A, C, T, G, T. And then on the opposite strand, the anti-parallel one, you must have the corresponding following the base pair rule at GC, remember? A bond with T, C bond with G, T bond with A, G bond with C, and T bond with A. So it is a base pairing rule that it must happen in this way. Now this is the second question that I'll answer in the next video. Try to think about a molecule that have a very similar structure as DNA. Okay. So the first question we talk about is that which molecule has a very similar structure as the nucleotide? Now this is the question. One is similar to DNA. So DNA nucleotide is like a monomer, and the nucleotide is like a polymer. Nucleotide is the monomer, and then DNA is the polymer. So think about these two questions when you have time. Then think about these two questions before you watch the next video. Before you watch the next video, and then I'll answer these two questions in the next video.